Hello everyone. We'll study momentum today. So in this lecture, we will talk about the momentum, the definition of the momentum, what does it mean, and the relationship to the applied forces. What do applied forces do to the momentum of the object? Then we will solve a few examples about the conservation of momentum and the collisions, several collision scenarios. Okay, so what is the momentum? Momentum is a property of an object that is in motion. So the momentum is given by P. It's a vector that is the product of the mass with the velocity. Velocity here is a vector and mass is a scalar. So the momentum has always a direction of the motion, the direction of the velocity, follows the direction of the velocity. The unit for the momentum is kilogram meter per second. So what is the relationship between the momentum and the forces? Any applied force on an object will lead toward a change in its momentum, such that WP, which is a change in the momentum, is given by the applied force over this time of the applied force. Momentum is a very useful property when it comes to understanding what happens in collisions. So how did we come up with this expression? The change in the momentum equals to the applied force over the time of the applied force. From a Newton's second law, we know that ma equals to F. And the acceleration here, A, is indeed delta V divided by delta T, and this equals to F as well. If we use the expression that we've just introduced, which is the momentum equals to the mass times the velocity, then delta P is m times delta V. Right? So if I substitute m delta V with delta P here, then we get the following: delta P over delta T equals to F, or delta P is indeed F times delta T. So any applied force on an object that has, as we will see during this time, it has a mass m, during delta T will result into a change in the momentum for that object. Let's look at this example, where in this example we have a baseball of a mass 0.15 kilogram that is traveling with a horizontal velocity of 38 meters per second west. After the ball is hit by the bat, it has a horizontal velocity of 51 meter per second east. What is the change in momentum of the ball? A. B. If the baseball is in contact with the bat for 1 millisecond, what average force does the bat exert on the ball? Neglect friction effect. So here we have a baseball, that has a mass m. So m is 0.25 kilograms. And this ball is coming west with a velocity of, let me call this one here v1, that is 38 meters per second. West. After the hit, after the ball is hit by the bat, it has a horizontal velocity of v2 as 51 meter per second east. What is the change in momentum of the ball? Now, if we calculate P1 and V1, let's assume that the positive direction for X is in this direction, then P1 is 0.15 times the velocity 38 P1 is 5.7 kilogram meter per second west. P2 is 0.15 times 51. P2 is 7.65 kilogram meter per second east. The change in the momentum delta T, that is P2 minus P1, taking west as the positive, then P2 is minus 7.65 minus P1 is 5.7, then delta P is minus 13.35 kilogram meter per second. So this is the change in the momentum. And as you can see here, based on the positive direction toward the west, I got delta P to be negative, which means I can say delta P as 13.35 kilogram meter per second east. If the baseball is in contact with the bat, if the baseball if the baseball is in contact with the bat for 1 millisecond, what average force does the bat exert on the ball, assuming frictionless? So in this case, if this is A and this is B, in this case, I know delta P equals to F times delta T, and F is delta P divided by delta T. F is 13.35 divided by 1 millisecond, which is in second, 24 minus 3, and F is 13.35 10 to the power 3 Newton, and the direction is following the same direction of the delta E, which means it is east as well.